So hello students, in this lecture we are going to study Jacobi's iterative method. So at the beginning of the lecture itself we have seen two types of method to solve the linear simultaneous equation. One was direct method. In direct method we have seen two methods, that is Gauss elimination method and Gauss-Jordan elimination method. In iterative method there are two methods. First is Jacobi's iterative method and the second one is Gauss-Seidel iterative method. Now we will begin with Jacobi's iterative method. So again, consider a system of equation having four unknowns. These are the linear simultaneous equation. Which are the unknowns here? x1, x2, x3, x4. These are the unknowns here. So we have considered a set of equation with four unknowns. Now what we have to do in Jacobi's iterative method? First, we have to write this equation in terms of unknown variables. Means which are the unknowns here? x1, x2, x3, x4. So what we have to do? We have to write this first equation in terms of x1. We have to write this second equation in terms of x2. We have to write this third equation in terms of x3, and we have to write this fourth equation in terms of x4. So see here, we have considered here this first equation, we have considered it here. a11 x1 plus a12 x2 plus a13 x3 plus a14 x4 is equal to b1. So we have to write this equation in terms of x1. So we have taken this term a11 x1 on the left hand side, whereas all the remaining terms we have shifted these remaining terms on the right hand side. So see here, what are the terms on the right hand side are b1. See here, this is the b1 and these are the terms shifted on the right hand side. So b1, this is here plus a12 x2, it will become minus, so a12 x2. This is plus a13 x3, so it will become here minus a13 x3. This is plus here a14 x4, it will become minus a14 x4 here. So till now also we have not converted this equation in terms of x1. This coefficient is remaining over here. So we will shift this coefficient to the denominator side. So by simplifying, this x1 will become 1 upon a11. In square brackets we have written b1 minus a12 x2 minus a13 x3 minus a14 x4, square bracket complete. So what we have done, we have written this first equation in terms of this x1 variable, or in other words we can say that we have written this x1 in terms of another variables, that is x2, x3, x4. Similarly we will write for other equation and it is written as follows. So see here, so you can see here this second equation we have written it for x2 variable. So x2 is equal to 1 upon a22 b2 minus a21 x1 minus a23 x3 minus a24 x4. Similarly, by considering the third equation, we have written this in terms of x3, that is x3 is equal to 1 upon a33 into this b3 minus a31 x1 minus a32 x2 minus a34 x4. Similarly, last equation we have written in terms of x4. So x4 is equal to 1 upon a44 b4 minus a41 x1 minus a42 x2 minus a43 x3. So what we have done, we have expressed these unknown variables in terms of other variables. Our aim is to find the value of these unknowns x1, x2, x3, x4. So with the in Jacobi's iterative method, we have to do this by first forming this kind of equations. So after that what we have to do? After that, see here, let this x1 raised to k, x2 raised to k, x3 raised to k, x4 raised to k. So what does it mean? It means x1 raised to k, it means value of x1 in kth iteration. x2 raised to k, it means value of x2 in kth iteration. value of x3 in kth iteration, value of x4 in kth iteration. Now what is this k? We have considered a random variable, that is k here. You can also consider it as n or any other variable. So k is nothing but the just a normal iteration that we have considered over here. It will just denote us the value of this x1 in so and so iteration, means it will denote this value of x1 in that respective particular iteration. So see, we are going to see the next page here. See on the next page, as you can see here, previously we have seen x1 raised to k, x2 raised to k, x3 raised to k and x4 raised to k, that were the values at kth iteration. Now if you want to find the value of next iteration, then you can write it as x1 raised to k plus 1, x2 raised to k plus 1, x3 raised to k plus 1, x4 raised to k plus 1. See here, again see here, why we have written here k plus 1 here, because we want to obtain the value of x1, x2, x3, x4 at next iteration, and our first iteration in this case was kth iteration, and our second iteration, or you don't consider it second iteration, just consider it as next iteration. Our next iteration is k plus 1th iteration. So in order to find the k plus 1th iteration, that is next iteration, from x raised to k, x1 raised to k, x2 raised to k, x3 raised to k, x4 raised to k, that is from values at kth iteration, you want to find it the next iteration, then you have to consider this x1 raised to k plus 1, x2 raised to k plus 1, x3 raised to k plus 1, x4 raised to k plus 1. So these are the values of that particular unknown variables at k plus 1th iteration, that is nothing but the next iteration. So the equation number 2 will become, so which is the equation number 2, I forgot to mention here. So see again the previous page. So see here, so this is my equation number 2, this is my equation number 2. We have already discussed this, so let's move on to next page now. This is equation number 2, that is x1, x2, x3, x4, this whole considering the equation number 2, this whole will become the equation number 2. So move on to next page now. See here, yes, now see here, now we want to write these terms, that is x1 raised to k plus 1. So see here, whenever we are going to write this x1 raised to k plus 1, all the remaining terms we have to write in terms of k here. See here, so whenever we want to find next iteration, that is x1 raised to k plus 1, so it will become 1 upon a11 b1 minus a12 x2 raised to k minus a13 x raised to k minus a14 x4 raised to k. Again second term, consider this second term, that is x2 raised to k plus 1, 1 upon a22. See here, all these terms will going to have k at their power. So x1 raised to k, x raised to k, x4 raised to k here. Similarly x3 raised to k plus 1 will become 1 upon a33 b3 minus a31 x1 raised to k minus a32 x2 raised to k minus a34 x4 raised to k. Similarly the last term, that is x4 raised to k plus 1, it is 1 upon a44 b4 minus a41 x1 raised to k minus a42 x2 raised to k minus a43 x3 raised to k. So we have written this formula in terms of k plus 1. So we have written all the unknowns in terms of k plus 1. So this is basically the Jacobi's iterative formula that we have to use while we are solving different kinds of numericals. So what we have to do, we will always start with k equal to 0. This particular condition will be always mentioned in your numerical. If it is not mentioned, then by default you have to consider k equal to 0, and you have to take the initial values as x1 raised to 0. Why 0 I have taken here? Because I have considered here x1 raised to k, x2 raised to k, x3 raised to k, x4 raised to k. So the value of k is 0, so I have written here x1 is to 0, x2 is to 0, x3 is to 0, x4 is to 0, and these whole values we have to consider it as 0. Why we have to consider this as 0 and why we have to start with 0? Because in order to obtain the values in the next iteration, so we will start with 0. So see here, whenever we will consider the value of k as 0, so it will become x2 raised to 0, x3 raised to 0, x4 raised to 0, and that value will be replaced by 0 only. And see one more important here, one more important condition over here, that whenever we are going to consider a k equal to 0, so it will become x1 raised to 0 plus 1. So 0 plus 1 is 1, so it will become x1 raised to 1. So it will give me value of x1 at first iteration. Similarly, it will become x2 raised to k plus 1, that is 0 plus 1 is 1. So x2 raised to 1 will give me value of x2 at first iteration. Similarly, I will get here x3 raised to 1, so it will give me value of x3 at first iteration. Similarly, it will give me x4 raised to 1, so it will give me value of x4 at first iteration. So this is nothing but the Jacobi's iterative formula that we have to use here. Why it is called iterative method? Because we have to apply the same formula again and again. At every iteration we have to apply the same formula again and again. So in the numerical itself they will provide us that you have to solve up to so and so iteration. If they ask you to solve up to 5th iteration, then you have to stop at the 5th iteration. If they told you that solve up to the digits correct up to 3 decimal places, then you have to go on solving till the answer is repeating up to the 3 decimal places. One more important thing over in this Jacobi's method is that you have to always check all the diagonal elements. You have to always check that all the diagonal elements are dominant. Means see here, you have to check that which are the diagonal elements here first. This is a11, a22, a33, a44. These are the diagonal elements, and these diagonal elements should be dominant. Now what do you mean by dominant? Dominant in the sense is that this particular a11 should be highest among among all this coefficient of x1. Similarly, this a22 is another diagonal element. This should be highest among all the coefficients of x2. Similarly, this third diagonal element a33, it should be highest among all the other coefficients of x3. Similarly, this a44, it should be highest among all the coefficients of x4. So first we have to check these diagonal elements are dominant. Dominance means it should be highest from the rest of the elements. A22, it should be highest in the second column. A33, it should be highest in the third column. A44, it should be highest in the third column. So don't worry about this condition. In the examination they are always provide you they will always provide you the numerical in the dominant way. Means all these particular diagonal elements, these are always dominated, so you don't have to rearrange the equations. But there may be some case in which they will provide some shuffled equation. At that time you have to rearrange this equation. So always remember this a11, a22, a33, it should be dominant, it should be higher in their respective column. If they are not higher in their respective column, then you have to rearrange the equation. So this is Jacobi's iterative method. We will conclude today's lecture. In next lecture we are going to see some numericals on Jacobi's iterative method. Till then, thank you.